Alright, for problem 1A, first we need to see that it gives us this Venn diagram. A quick overview. If bicycle is on this side, that means everybody that's in this entire circle for bicycle owns a bicycle. Everyone that exists in this whole bubble for skateboard owns a skateboard. These people right here, they belong to both bubbles. So they belong to the bicycle bubble, and they also belong to the skateboard bubble. So these people own a bicycle and a skateboard. They own both. These people out here don't belong to either bubble, so that means that they must not own a bicycle and they must not own a skateboard. So they don't own a bicycle or a skateboard. They own neither. For part A, it says find A, and then it says find the probability of A. If I say find A and I don't ask for the probability, you don't see a P, I don't say what's the probability, nothing like that, just find it, that means we're going to be writing out this set. So the set notation always starts with a brace and ends with a brace. For set A will always be the bubble on the left and B will always be the bubble on the right. So if I'm finding A, I'm just going to list everything that exists in this bubble, keeping in mind that these people do own bicycles, so they will belong to set A. So I've got Ryan, Sarah, Mariko, Nina, Dion, Jake, Mike, Linda, and Rose. I abbreviated. And then from there, so that's the first part. The second part says find the probability of A. Anytime I ask for the probability, I'm not going to ask for just the number of outcomes. It needs to be a fraction out of the total number of people involved. So I'm going to go ahead and count up how many people I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's a total of 15 people. These people, we need to make sure we still count them because they were part of the survey. Then, if I'm finding the probability of A, I'll count how many people belong to set A out of the total 15. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 15. We can then simplify this. We can say this is 3 out of 5 or 0.6. You can either put a fraction or a decimal. Either one will work. If you're going to put a fraction, please simplify your fraction. For B, it's asking for the union between A and B. So A union B, again it just says find, so it's going to be the set. Find A union B. Remember, the union is like the family reunion. Everybody from both sides, including the middle. So I'm just going to write everybody here. So that'll be Ryan, Sarah, Mariko, Nina, Dion, Joe, Mike, Linda, Rose, Brett, Juan, and Toby. Then from there, it tells me to find the probability of A union B. So I'll count all these up and put it over the total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 15, which is the same as 4/5 or 0.8. Let me make that look a little more like an 8. 0.8. Now it tells me to find A union B complement. This little dash is very important. It means everything except A union B. So up here I had A union B and I listed everything that was in both bubbles. So A union B complement will be everything that's not in the union, or everything that's not going to take place here. That'll be Amy, Gabe, and Abby. So I've got Amy, Gabe, and Abby. Remembering to close the braces every time. And then the probability of A union B complement. So we can do this a couple different ways. If A union B has 4/5 of the people, then everything except that will be 1 minus 4/5, which will give me 1/5. Or I could count it up and put it over 15 to get 3 over 15 or 1/5 or 0.2. When I add these together, the union and the complement of the union, I have to get 1. That'll be true for anything that has a complement. A and A complement, when you add them together, will be 1. B and B complement added together will be 1, because basically what you're saying is something plus everything else. So that will always give you the total probability of 1.